Okay, good morning, CCTI AP Calculus. Mr. Pashar here. I want to continue today on the lecture I started the other day on integrating by parts. So we saw that integrating by parts is another great method we have to break down integrals essentially that can't be integrated by the means of substitution or manipulation or trig identities for the most part. So today we're going to look at ones that are a little more complicated. And remember that integration by parts has its counterpart with derivatives, which is the product rule. Okay, remember when we integrate by parts, we say fg minus gf prime's integral. So I want to do another example or two with you. So here's one that's actually from the textbook, the integral of x cosine of 5x dx. So what happens usually with an integral by parts is that there's always mix of other types of integration in there. And as you're going to see, this is going to have u substitution as part of it. And the more you do of these, the more you're not even going to have to write the u substitution part, because I think you're just going to kind of see it happen in front of you. So here's the situation we have: the integral of x times cosine of 5 to the x, 5x dx. So once again, u substitution won't work here because that will not knock that x out of there. So this is a great candidate for parts. So let's set up our tab. We have f and f prime, g prime g. So remember, whatever we choose for f, we find its derivative. Whatever we take for g prime, we have to integrate to get g. Okay? Now, this one isn't too bad. You have x versus cosine of 5x. Now, typically, this is what's going to be integrated. This is what we're going to take the derivative, because the derivative of x is just 1. So that's really nice. And this will be cosine of 5x. Now, I know right away what that's going to be when I integrate it. You may not know right away what it is. So you may have to go off to the side to figure it out. But what g will be is 1/5 sine of 5x. And I think you may see how that works without doing any work. Knowing that u is going to be 5x, the derivative of 5x is 5. So that's going to be du over 5. So that means you're going to have a 1/5 hanging out in front. But if you need to go off to the side and integrate this, you certainly can. So I would, do that if you're not too sure. But we have all our pieces set up here now, so we're ready to roll. So our integral, x cosine of 5x dx, is equal to fg minus the integral of gf prime. So now we're just going to put all the parts together essentially. F is x, g is this 1/5 sine of 5x, minus the integral of gf prime. So g is the 1/5 sine of 5x. And we get a nice break here because f prime is 1. So it's literally times 1, but we don't have to show it. So it's just 1/5 sine 5x dx. So over here, I'm just going to rewrite this 1/5 x sine of 5x. Now, I'm going to write this as minus 1/5 the integral of sine of 5x dx. And once again, doesn't this integral here look very similar to cosine of 5x? It's going to have that same result. When you take the integral of sine, it's minus cosine. So u would be the 5x. And again, if you have to go off to the side, go ahead and do it. But when we integrate this thing, this is going to give you minus 1/5 cosine of 5x. So you're going to have a sign change here. So this is going to become plus 1 over 25 cosine of 5x plus c. So I did a couple steps there in one. If you need to go off to the side, by all means do so. But this right here, like I said, is negative 1/5 cosine of 5x. And the 1/5 here times the 1/5 is 1 over 25. Negative times the negative makes that a positive. So this is a classic example how a lot of times with parts, there's always other integral tricks that's embedded in it. In this case, this requires u substitution. But again, nothing out of the realm of the impossible. So I encourage you to pause the video here, see if you could go back and do this bad boy, and then we'll come back and look at another example. Okay, welcome back. I hope you're able to tackle this one. Let's look at an interesting one that that has popped up. It's actually one of my lecture examples I gave you, but it actually appears as one of your assignment problems. This integral here, the integral of the ln of 2x plus 1 dx. Very interesting integral. Obviously, on the surface, u substitution will not work with this guy here, so we're going to have to go ahead and use parts. Now, we know in our minds right away what this would look like. If we had the integral of ln of x dx, right, that would be x minus x ln x plus c. So we're going to kind of see where the answer is going to be very similar to that at the end, just slightly modified because of this 2x plus 1 as the guts. I'm looking out my window here. There's a groundhog back there, and I'm thinking that devil better not destroy my garden, as I'm going to be planting tomatoes. I already have a bunch of flower bulbs and stuff already in my backyard. Look at that freaking woodchuck. Okay, anyway, here we go. We have f and f prime, g prime and g. So again, pick wisely. Well, this is one whole unit, and it's also multiplied by 1. So we can't let 1 be here, because when you differentiate 1, you get 0, and that'll kill off the parts. So we're going to have to make f the ln of 2x plus 1. That makes g prime 1, and when you take the integral of 1, you get x. So now we just got to figure out what's the deal with this. So we have to think back a little bit. We want to take the derivative of the ln of 2x plus 1. So remember what the template is. It's u prime over u. So your u would be the guts, 2x plus 1. So what is f prime going to be? That's going to be 2 over 2x plus 1. Okay, so that's a little side trip back to late fall, early winter, when we did derivatives. Okay, so we're in good shape. We have our parts now. So we have fg minus the integral of gf prime. So let's piece these things together. F is the ln of 2x plus 1 times g, which is x, minus the integral of gf prime. So that's going to be x times 2 over 2x plus 1 dx. Okay, so it looks kind of crappy. Let's try to just rewrite this a little bit here with algebra. This would be x ln of 2x plus 1 minus the integral of 2x over 2x plus 1 dx, differential dx. Have we seen anything like this before? I don't know. I don't think so. It doesn't look all that difficult, right? You look at it, a 2x over 2x plus 1, you want its integral. It seems kind of tame, right, when you look at it. But quick inspection would show you that substitution is going to fail, right? Substitution is certainly going to fail because you'll never knock out the x, no matter which u you pick. If you pick u to be 2x or you pick u to be 2x plus 1, you're not going anywhere. So I have to contribute this trick to my Calculus 2 professor at King's College. So I'll shout out to Dr. Ohashi from King's College. He would say that we need to use a slick out trick here in this case, and that's exactly what we're going to do. So let's come off to the side here. If we have 2x over 2x plus 1 dx, we could rewrite this guy in this manner. 2x plus 1 minus 1 over 2x plus 1 dx. So look what I did here. I didn't do anything illegal. I added 1 and I took it away, right? So it's a net change of 0, right? It's gone. But when you do this trick that I was taught, this will help us to reshape this integral, because look what this, it could be rewritten as. The integral of 2x plus 1 over 2x plus 1 plus negative 1 over 2x plus 1 dx. You see that? We were able to break this integral up into these two pieces. And look how nice this is. 2x plus 1 over 2x plus 1, that's everything we would imagine in our wildest dreams we would like to happen. So that's the integral of 1 dx, right? And then we have another integral here, which would be negative 1 over 2x plus 1 dx. So I will leave it to you to integrate these two bad boys. These are very easy to integrate, shouldn't have much problem here. This becomes x, of course. This requires substitution, but it's not all that bad. So now what we're going to do is come back over here. This is x ln of 2x plus 1 minus, and I put a bracket because we're going to look at all of this stuff that we get here. This is going to be x, and we're also going to have, by the same token now, when we go ahead and simplify that, 1/2, and it will be a minus, so the minus 1/2 ln of 2x plus 1 and plus c. So I just had enough room to squeeze that in over there. Okay, so when you do this, it's going to go ahead and read as x minus 1/2 ln of 2x plus 1 plus c. This gives you the x, this gives you the negative 1/2 ln of 2x plus 1. Again, which you could easily be able to do on your own, go back and check it out, just to save some time. So this would be your final answer. So that one required a little bit of a trick, but once you got the trick, it wasn't too hard to do. You're able to easily integrate, or should be able to easily integrate those pieces, okay? So I really would encourage you to pause the video here, go back and see if you could figure this out on your own. I think once you get past this trick right here, the integration is quite simple for you guys at this point. So I'll take a break and we'll come back and look at one more example. Okay, hope you guys were able to take care of this one. I have one more example for us. Let's look at one that looks like this. The integral of p to the 5th ln of p dp. I try picking ones to avoid the t. I don't like using the t as a variable, just like you guys don't either. So once again, substitution will not work for us here, so we're going to have to go ahead and do parts. So let's see what we want to do. Well, this time, we're not going to go ahead and put ln of p as the, well, we don't want to do it as the integral because that's going to be disaster. So f is going to be ln of p, so its derivative is this 1 over p. And g prime will take as p to the 5th. So when you integrate p to the 5th, that gives you p to the 6 over 6. Or you could write as 1/6 p to the 6th. So now we have fg minus the integral of gf prime. So f is the ln of p times g, which is p to the 6 over 6, minus the integral of gf prime. So g is p to the 6 over 6 times f prime, which is 1 over p dp. And again, as you probably see when you do these integral problems, there's a lot of times we could do algebra first, get things out of the way. So I'm just going to write this as p to the 6 over 6 ln p minus the integral. Notice here you have a p to the 6 on top, p on the bottom. So that nets p over 5, p to the 5 over 6 dp. If you want to, you can slide the 1/6 outside the integral and just leave that as a p to the 5 dp. Make it a little easier for you. And this is a wonderful little integral, because the integral of p to the 5 is p to the 6 over 6 plus c. And just like that, we're going to go ahead and say this is p to the 6 over 6 ln p minus 1 over 36 p to the 6 plus c. How about that? A little bit better than that last example. So, I hope these examples help you as you navigate through your homework. I think now, with all these additional examples, you'll be able to do anything that you're faced with in the textbook. Okay? So again, if you have any questions, please feel free to call or email, and I'll do my best to help you out to do your homework. Until then, it was great meeting with you online, my AP Calc students, and I hope everybody remains safe, healthy, and well. And until next time, I will see you when I see you.